I'm at 3 students. Today we are going to go over complex numbers and operations involving them. So we kind of touched on complex numbers or imaginary numbers specifically. Now, a complex number is a number that has a real part and an imaginary part, essentially imaginary numbers. Now, something related to that is called a complex conjugate. And it has equivalent real parts and opposite imaginary parts. So, for example, the complex conjugate to 7 minus 8i is 7 plus 8i. The complex conjugate to negative 2 plus I is negative 2 minus I. Notice how the real part is the same, imaginary part is opposite. Now, one thing I'd like to add here is if you have just an I, right, that's the same as like 0 plus I, right? So its complex conjugate is going to be 0 minus I, which ends up just being negative I. So like I and negative I are complex conjugates of each other. All right. Now, why is this important? Well, if you multiply two complex conjugates together, what ends up happening is the imaginary part in the middle cancels out, and you're going to be left with a real number because you end up with an I squared. The I squared becomes a negative 1, and you end up with two real numbers, which then you can combine. Now, much in the same way that we don't like, in math, we don't like having radicals in the denominator, that's like a square root in the denominator, we don't like having imaginary numbers in the denominator. So, we go ahead and multiply the numerator and denominator by the complex conjugate of the denominator so that the denominator no longer has imaginary numbers in it. So, for example, what we would do here is the complex conjugate of our denominator here is going to be 2 plus I. Now, remember when you are dealing with fractions, what you do at the top, you need to do to the bottom so that the fraction stays equivalent. It's the same thing like when you have 1/2 and you're trying to get a different denominator, you multiply the top and the bottom, I don't know, let's say by 4. Well, that gives me 4 over 8, which is equivalent to 1 over 2. So that's why we have to make sure whatever we do to the top, we do to the bottom. So on top, this is just going to be like a distribution situation here. So we end up with 20 plus 10i. Now on the bottom, we have to go ahead and FOIL this out. So we end up with 4 plus 2i. We distribute the negative I minus 2i minus I squared. Then we can simplify the denominator here. The two middle parts cancel out. The top stays the same here. Now, I squared is negative 1. All right, so we can replace I squared with negative 1. We learned that previously, and then we just continue to simplify the bottom here. So I've got, 20 plus 10i. And then we end up with 4 plus 1, because like it's minus negative 1, which gives us 20 plus 10i all over 5, which we actually can simplify. What you want to do is see if you can pull anything out of the top that you can simplify with the bottom, which I can actually take a 5 out of the top, factor a 5 out of the top, I should say. And I end up with, 4 plus 2i all over 5. These guys cancel, and I am left with 4 plus 2i. And again, notice how they wanted the answer written in the form a plus bi, so you got to make sure you simplify it as much as you possibly can. All right, let's go ahead and try the next one. So again, we don't like having these i's in the denominator. Now, one thing I want to point out is you cannot just go through and like cancel these guys. And the reason for that is whenever you're canceling something on the top and the bottom, it needs to be multiplied with the other things on top. So like here, we were allowed to cancel this because this quantity was being multiplied with this quantity. And that's why you were allowed to cancel them. However, something like this, these guys are not being multiplied together on top. They're being added. And when you have that, you're not allowed to just cancel things. All right. So we're going to go ahead and multiply the top and the bottom by the complex conjugate of the bottom, which is going to be 5 plus 2i. Again, the real part stays the same, the imaginary part gets flipped. So I have to go ahead and FOIL on top here. I get 20 plus 8i and 15i plus 6i squared. And then on the bottom, I get 25 plus 2i, no, not 2i, sorry, plus 10i, minus 10i, minus 4i squared. So now I got a lot of simplifying to do. On the top part here, these guys can get combined. They're like terms. You essentially treat i's like x's until you get an I squared, and then you can go ahead and simplify using -1. And this I squared going to become a -1. These guys end up canceling, and this guy becomes a -1. So on top, we get 20 plus, and then 8 plus 15 is going to give me 23i. And then this gives me 6 times -1. And then on the bottom, I get 25 minus 4 times -1. Now, of course, we can simplify this a little bit further. On top, we get 20 plus 23i. And then 6 times -1 gives me a -6. -4 times -1 gives me a +4. And these guys are going to come together. Now, remember, whenever, and I guess actually I don't know if I've emphasized this, whenever you're writing complex numbers, the real part comes first, the imaginary part comes second. So when I combine these like terms, the 20 and the -6, I want to make sure that I write that 14 first. So I get 14 plus 23i, and then on the bottom I get a 29. Now you would go ahead and check to see if there's anything you can simplify out of the top that will cancel with the bottom. 14, you can only take like a 2 and a 7 out, and I guess a 14 in theory. And then a 23, that's a prime number. Only factors are 1 and 23, so there's nothing I can even factor out of the top to attempt to cancel with the bottom. So our final answer would be this. All right. And then here, again, we have an imaginary part in the denominator. We don't like having that. Now, if you recall, the complex conjugate of I is -i. So that's what we're going to multiply the top and the bottom with. So on the top, we get, -2i. No, +2i, because it's a -2 times a -1. My apologies. So we would get +2i, and then -2i squared. And then in the bottom, we would get -i squared. So I get 2i minus 2 times -1. Remember, you replace these with -1. Then we get negative times -1. So we get 2i plus 2 all over +1. Now, the top part, we want to make sure it's in the form a plus bi. So we end up with 2 plus 2i. So remember, you want to put the real part first. That's why I switched the order. And that's all over 1. Well, dividing something by 1, your denominator can essentially go away. So we are just left with 2 plus 2i.